Hi guys, in this video we are going to discuss what's meant by the power, and here the different thing in the electrical fundamental is we are going to discuss about three types of power. So why we are having three types of power and what they mean. So in this video we are going to discuss about these things. Also we are going to discuss about the basic introduction for the power factor. If you don't subscribe to our channel yet, please do that faster. And if you have any doubts or if you like to watch our previous videos, I have given the link in the description so you can always watch that. Okay, without wasting our time, let's look at the main thing. Okay, when we are studying about the electrical power, there are mainly three types of power. One is known as apparent power, and the next one active power, and the third one reactive power. So first of all, we need to identify before these three types of power, we need to know what's going to happen when there is a AC circuit. Actually, we knew three items or three basic elements in the AC circuits. They are, the first one is resistor, and the second one is capacitor, and third one is inductor. So we need to know how they function. First of all, we need to know how they are going to function. So after that only we can differentiate what are the differences between these two power, and from that only we can explain these types of power. So first of all, we need to identify what's going to happen over here. Yeah. So if you consider the resistor, actually we knew that when there's a current flow through that resistor, the heat is going to dissipate from that resistor, which simply means if we are using it like in a heater, when you pass the electricity through that, it's going to dissipate the heat, so we are going to use that heat energy. Likewise, when there is a connection or when there is electrical through that resistor, it's going to dissipate that energy. Most probably it's going to dissipate as a heat. So when we are considering about the capacitor or inductor, the main thing is when we give an electricity to that capacitor, is going to store that charge, and not when the current is in the negative side, when the current is in the opposite direction, it's going to lose that energy, which simply means if that capacitor store that power in one time, in half of that oscillation, in the another half is going to release that energy, which simply means it's not going to dissipate at all. It's going to store that energy as electrical energy. Likewise, if we consider the inductor, it's going to do the same, which simply means it's going to store that energy as a magnetic field. After that half oscillation of the sinusoidal waveform, it's going to return that energy to that circuit. So in these two, likely the capacitor and the inductor, it's going to store and release that energy and not going to use that, which means it's not going to dissipate that energy. So that are the ideology behind these powers. So we can't tell that these two powers are same, because when we are considering about the resistor, the power related to the resistor, it's going to dissipate that. We can't actually restore that, so we are going to use that heat energy to do our works, or we are going to use that dissipate energy to do our works. However, when we are considering about the capacitor, we can't get that energy, or we can't get use from that. So that's the main problem. So however, it's going to store that energy, so we need to show that. However, we need to make some differences so that we have mainly two items. So first of all, so that's the main concept. That's why we are having these three types of power. First of all, let's look at the active power. When we are considering about the active power is the energy which is going to dissipate, which simply means the active power is the power stored or power used by that resistor, or power get by or power dissipates by that resistor is known as active power. So you need to know what's meant by the active power. The reactive power simply means the power, let's say in an oscillation, in the sinusoidal waveform, when the current passes through that capacitor or inductor, it's going to store and return that energy or return that power. So the storing power is known as the reactive power, which simply means it's not going to be the waste, or we are not going to use that. It's going to return that power when the current changes that direction. In an alternative current waveform, the current direction is going to change. When it's in the positive side, the current in the positive side is going to store that energy. After it's going to the negative side, the current goes to the negative side, the capacitor is going to release that energy. So however, we are going to show that power, we are going to consider that power as reactive power. However, note that it's not a base, or we are not going to use this one. Active power is the power we are going to get from that total circuit, because actually we knew that if there are three elements in a circuit, let's say resistor, inductor and the capacitor. If we have the three elements in a AC circuit, we can directly tell the active power is gained from the resistor only, which means the power we are going to get from that circuit or that element would be the active power. The reactive power is stored in that circuit and you return to that circuit always. So we are not going to consider the reactive power as our used power. However, we are going to consider the active power as used power. The apparent power simply means the mathematical sum of these two powers, active power and the reactive power, is known as apparent power. So these are the terms you need to know. However, these equations are enough to remember. So the reason why I'm doing this video is, the reason behind this is, actually you need to know what's meant by these three terms. I have searched some relative YouTube videos. They have nicely explained, but they have given some more explanation. So I think it would be a little bit easier to understand. Okay, so the next thing is why here we have get this type of equation. So when you are considering about the active power, it's going to be the Vi cos phi, and the reactive power equation would be Vi sin phi. I'm going to tell why we are going to get these types of equation in a little bit. And the total power, the apparent power, would be Vi, which simply means, actually we knew that if there is a power called Vi cos phi and Vi sin phi, when we are considering about these two power, when we are going to add these two, we need to square this up, and if we add these two, we are going to get V squared I squared cos squared phi plus V squared I squared sin squared phi. If we add them, we are going to get V squared I squared. If we get the root value, it's going to return this value, Vi. So you can directly use the apparent power would be will have the equation of Vi. So these are the things you need to know. And the active power, the unit for that active power is watt, and the reactive power equation is VAR. Sometimes they will write in simple letters, however you can see in the capital letter too. And when you are considering about the Vi, the apparent power, we are going to written in VA, which simply means it's going to be it's going to have that volt ampere, and this is watt, and this would be volt ampere reactive. Reactive simply means it's going to store that energy and return that to that electrical circuit. So these are the things you need to know. Okay, let's look at why we are going to use this one. Why are we going to use this Vi cos phi? Can't we use the Vi sin phi over here? Let's say there is a circuit. I'm going to draw some phase diagram. Let's say this is the phase diagram I, and this is the voltage V. You can draw it in any side, so I'm going to draw a random circuit. So this is V and the random phase diagram. So let's say this is the angle between these two phases, which is phi. Actually, we knew that active power is the power we gain from that resistor. So when we are considering about the resistor, actually we knew that the resistor part, the voltage between the resistor can be get by using this. If we divide this voltage phase into two, let's say I'm going to divide it in these two. In these two, I can directly tell this part would be the resistance part. The voltage between that resistance would be this, and this would be voltage between that inductor. As voltage is leading, we can tell inductor. Either it can be capacitor, it also consists of capacitor, and don't mind that. However, in this here you can directly tell this part is going to be the resistor part. Resistor, the voltage between resistor. How we can get this part is V cos phi. So when we are considering about the power, we actually know we need to multiply the voltage in that current. So resistor's voltage, we actually knew that it's going to be Vi cos phi into that I. So Vi cos phi. Likewise, if we are considering about the reactive power, which simply means this part, we can directly tell it's going to be V sin phi. The reactive part is, we are getting the reactive part from the capacitor as well as inductor. So mainly it's going to be in this side, V sin phi. So we can tell that we are going to multiply the voltage, which is V sin phi, in that capacitor inductor, and we are going to multiply by this I, so Vi sin phi. If you get these two totals, it's going to be Vi. But remember, sometimes you might get whether can't we use the direct sum Vi cos phi and the Vi sin phi. Actually, we knew that it's going to make a triangle, vector triangle, so use that. Some other further information is this cos phi is known as the power factor. We will do what's mean by the power factor in the next video, as it has many significant points over there. And the V and I values are RMS values of that voltage and I, so you need to know that. So these are the things you need to know. So let's see how what are the power we are going to get when we are using capacitor only and pure inductor as well as pure resistor. Let's consider about the pure resistor. So I'm going to consider about the pure resistor. So if I consider about the pure resistor, let's say what's the active power of that. Actually, we knew that if we use the pure resistor only, the voltage would be lies on the same line, where let's say this is I, the current through that resistor, and this would be the voltage. So from that we can directly tell these two are in the same line, which simply means this phi is going to be 0 between these two lines. The phase angle would be 0. So we can directly substitute that Vi cos, the angle would be 0. So Vi cos 0 would be 1. Actually, we knew the value for cos 0 is 1. So from that we can tell this is going to be Vi. Likewise, if we find for reactive power, Vi sin into 0, actually we knew that sin 0 would return the value of 0, so that is going to be 0. So from that we can directly tell that active power, actually we knew that when we are considering about the pure resistor, we are going to get only one power, which is active power, which means it's going to dissipate its energy, or it dissipates that power. So likewise, actually we knew that it's not going to store that power anyway, so the answer would be 0. The reactive power is 0 for the resistor. Likewise, you can do it for inductor and capacitor. Now let's look at for capacitor. Let's say that's a pure capacitor. So when we are considering about the pure capacitor, it's going to be like this one here. This is I. Actually, we knew that for capacitor, it's going, the voltage is going to lag the current, so it's going to be like this. So the angle between these would be minus 90 or 90. You can take it like 90, no problem at all. The angle between these are 90. So the main thing is, actually when we are considering about the active power and the reactive power in engineering terms, we usually use the voltage as the reference line. However, in some videos you can see they can take the I as the reference voltage for calculating this phi. Normally when in the engineering usage, normally we take that V as a phasor reference line. So it's going to be the I, so it's going to be 90 of that. So if I consider for this, it's going to be Vi cos phi, it's going to be cos 90. Actually, we knew that cos 90 is 0. From that we can write it like this. 0 simply means in a capacitor, it's not going to dissipate the heat. Likewise, if you consider this part, reactive part, it's going to return the same answer we have got for this one, where I sin 90. From that we can directly tell it's going to be Vi. So I have already mentioned that these values can be directly, you can use this when you consider about the active power or reactive power. You can use this value if they have given the pure resistor or pure capacitor, as well as you can use it for pure inductors too. So these are the things you need to know. So I hope in some terms, if you for pure inductor, if you use that minus 90, you will be getting, let's say this is going to be 0 for that inductor too. Actually we know it's going to it's not going to store the power. It's not going to dissipate the power. It's going to store and return that. So it's going to have only reactive power. If you substitute the value Vi sine minus 90, actually we knew that it's going to return the answer in minus, which means minus Vi. So it's not a problem here, which means one time it's going to store that and it's going to release in one time. So when it's in this time, it's going to be plus Vi. After that, it's going to release that. That's why we are going to get that minus Vi. So it's not a problem. You can take it as plus. So these are the power. So you can directly use as the plus Vi. So these are the main thing you need to know about these powers. So the main difference between an active power and reactive power is the active power simply means the dissipate power, and the reactive power is we are going to store that power and going to release that when the current directions changes. So you need to know these two. I hope this video would be useful for you. If you have any doubts, please comment it below. In the next video, we will look at what's mean by the power factor, and we are going to do another question, interesting question from this power in the next video. Hope to see you in the next video. Thank you for watching.